So we were dealing with some velocity notes yesterday, so just a quick review here. Remember that I talked about the difference between distance and displacement, and the difference between speed and velocity. Okay. We talked about position time graphs, and we know that when there's straight lines like that, that means that the velocity is constant, right? And we refreshed our memory how to calculate slope. We talked about average speed is the distance divided by the time, and average velocity is the displacement divided by the time. Here's a quick example there. Here's another example. This one was average velocity, right? And again, these were all examples of constant velocity, and we learned that the slope, when it's constant velocity, the slope is going to have to be exactly the same throughout. So I just took a small interval here, and I got 0.5. I took the entire interval, and I got 0.5, because it's constant velocity. And then we got into what was known as variable velocity, okay, because you have to speed up and slow down, and when you speed up, the graph is going to be curved, and when you slow down, the graph is going to be curved as well. And this is called variable velocity, right? And then I showed you a little bit of calculus near the end, and Brett needs to put his phone away. And I showed you that instantaneous velocity is the slope of the curve at a single point, right? And to do that, you find the tangent line. You take your ruler. You take your ruler and you simply draw a tangent line that approximates the slope of the curve, right? Or you, well, yeah. Okay, so this is sort of where we left off. I know. I'll just put it here. Okay, so this is variable motion. Okay, so this is where we left off. So if you are jotting stuff down, you maybe want to start here. Okay. They are now. Okay, we'll do that today. So this is a graph with variable motion. The average velocity, so the overall average velocity. Now, how do we do that? Okay. So what we do is we're going to draw a line from the start to the finish, right? Now we're lucky in that the start is at 0. Okay. So well, it just means that you're not subtracting 0. That's all, right? So my rise is 7 minus 0. There it is right there. And my run is 11 minus 0. And so I get 7 over 11, or 0.64 meters per second. That is the average velocity for the entire trip. Is there any point in time when the velocity is exactly 0.64? How could we tell?
When it hits the line.
Right here?
Yeah.
Nope.
It's a guess.
It's a guess. What do you need, Connor? You need those graphs? One of those? Probably one of those. You were away yesterday, right? No? Oh, no. Okay. Okay, sorry. What I need to do is to find out when that velocity is the same, it has to be, the slope has to be the same. So what I'm going to do is I'm going to take this line and I'm going to move it around, and I got to find a place where the slope is about the same. About there. Roughly about there. The slope of the line is the same. Gage, you need to put the phone away and listen. Okay? So there's one place, and I think there's probably another place up there as well. Would you agree? Yeah. Okay? So there's 2 points. The slope is about 0.64. But those are the only 2 points. In fact, down here the slope is less. Here the slope is more. And there's the slope is more, and there it's less. It's exactly the same as, whoops, that was not intended. It's exactly the same as if you've got a test of, say, 60, and the next unit you got a 68. What's your average? 64, right? But you never actually got a 64. Same idea. Okay, so to find average velocity, we connect the start to the finish. Now, if I want to find the velocity between points C and D, how would I do that? Well, I would just draw a line between points C and D. Maybe I'll make that a different color so it's easier to see. Green. Okay? So to find the velocity between C and D, we're going to draw that line there, and then we're going to go, that's a rise, that's 4 minus 2, and the run is 6 minus 4. Right, so I got 4 minus 2 or 2, 6 minus 4, 2 over 2 is 1. Is the slope ever 1 someplace? Yeah, somewhere in there, and somewhere in there, right? Okay, so that's average velocity between 2 points, over the entire distance or between an interval. Now, if we want to do instantaneous velocity, we're going to have to actually do that tangent line. And here's an example of that. Okay, so the velocity at point C is found by drawing the tangent. You can find velocity over an interval. If it's an instantaneous one, you have to draw a tangent line. And I drew it right there. Now, actually, I'm going to get rid of that one, and I'm going to make it an actual line. Okay. Do I have to only have it that long, or could I have it longer?
Could have it longer.
Absolutely, right? Okay. It can be as long as I want, right? In fact, you might need to go longer to find an actual point that works good, right? These are called lattice points. Okay? Lattice points. I chose not to use them. I chose to just to pick some points right off there. I'm just going to zoom in a little bit here. Okay? Get rid of that line there so you can see a little bit better. I just chose to go with these endpoints right here. Right? And I went with this value being 3.2, this value here being 1.8, so I went 3.2 minus 0.8 or 2.4. I went with the x value here of 5.8. I went with the x value here of 2.5. And I've got 5.8 minus 2.5, giving me a slope of 0.73. Okay? So the slope at point C is 0.73. Just before point C, what would the slope be like, approximately?
I don't know.
Give me a number that would be appropriate for
4?
point before C, down here.
Oh, it'll be smaller.
Would it be more or less?
It'd be less. It'd be less because it's going as steep of a.
Isn't the graph curving up?
Yeah.
Which means it's getting steeper. So that means that here it's going to have to be flatter. So if I were to draw the tangent line in here, it would probably be like maybe 0.7, right? And farther up it would be like 0.8. Now sometimes I get kids that, like if I've got to do the tangent line right here, I've told you that it can't cross the line more than once. But that's only true if the curve keeps going at that sort of curve, right? Like if it goes up like this and then goes back down, is it okay if it crosses the line, like again way up here?
Yeah.
Yeah, it is, right? You're just sort of ignoring that. It doesn't really count because the curve changed, right? So that kind of thing.
Following on one curve.
Yeah, so basically the curve has to maintain its equation, kind of thing. Okay, so this is called instantaneous velocity. Okay, so by now you should know the difference between average velocity and instantaneous velocity over an interval and over an interval and at a particular instant in time. Okay, that is all that I really have today. I'm going to give you the rest of the period to work on the ladybug. It's due Monday, but I will gladly take it today. There are 5 of you that have not turned in the vector golf, so I'm going to give you the alternate ones. You're going to have to start over again, and I'll be handing those out right away.